Hello. Today we're having a look at a review of the probability topic that we have been studying so far in class. I just want to go through some of the key things so that you guys can have a go at the review exercise on page 179, 180. That's chapter 12's review exercise in the textbooks that you've taken home. If you don't have a copy of the textbook, that's fine. I will take a snapshot of the pages and I'll put them in the WhatsApp group so that you guys can have a look at those as well before heading on to distributions later on in the week. So, some really key things, some very simple things. What you always need to do is look at the information that you're given, look at the questions that you've got, and start trying to think about how you can use some of the probability laws in order to be able to work out what it is you're asked to find. So here, the first one, part A, asks us to find the probability of A. Given the information that we've got here, you might identify here that the probability of there's an A with a dash on it. Now remember what this means. This means not A. So you're given the probability of not A is 0.6, and you want to find the probability of A. So in order to do that, what we need to do is we need to take that away from 1. So 1 take away the probability of not A will give me the probability of A. So that's here going to be 1 minus 0.6, which is 0.4. So that's the probability of A just there. Nice easy one just to get started. This would likely be a simple 1-mark question. The next one here wants us to find the probability of the intersection. Now, given what we've got and what we've just found, we can use one of our probability laws in order to work out the intersection. So let's just have a little bit of a look at what that is. So we've got the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now this here is what's called the addition law. It can help us find out what the union, probability of the union of two events is if we know the individual probabilities and the intersection. Now if you look at what you've got here, this isn't particularly set up to find the intersection, which is what we're asked to find. So if we look back here at part B, you're asked to find the intersection. You want to find the intersection, but it's on the wrong side. So if you want to, you can rearrange it as it is. Personally, I would just substitute the values in and then rearrange from there. So you've got union is 0.58 equals the probability of A here, that's 0.4, plus the probability of B, that's 0.3. We found that out in part A, by the way. Minus the probability of the intersection. So we can start grouping things together. So I've got 0.58 is equal to 0.7 take away the probability of A intersection B. So now we can either rearrange this by taking the 0.7 over and then dividing by -1, or to be fair, the astute amongst you should probably be able to recognise that 0.7 take away something gives me 0.58. Well, I only need to take 0.12 off 0.7 in order to find 0.58. So here we've got the intersection, therefore must be 0.12. Just run through that again. 0.7 take away 0.12 will give me 0.58. So that's what we've got there. So here it's not only useful for finding the union, you can also use it for finding the intersection or any of these two individual things if you know one of the other three. This is a formula you need to remember. It's a really important one that the examiner will like to use a lot. So part C here says, hence state whether these events are mutually exclusive. Now we know that mutual exclusivity of events is all to do with the fact of the value of the intersection. So here the value of the intersection is 0.12, so that's not equal to 0. If two events are mutually exclusive, they cannot happen at the same time. Therefore, the intersection would have a probability of 0. So here, the probability of A intersection B is equal to 0.12, which is not equal to 0. Therefore, they are not mutually exclusive. So we've got two more things left. This one here wants us to determine whether these events are independent. So if we're determining whether the events are independent, again, what we're going to need to do is make a decision based on the intersection and based on the individual probabilities. So I'm going to squeeze this on the bottom here. So part D, the probability of A multiplied by the probability of B. If when I multiply the individual probabilities together, I get the probability of the intersection, then they are independent. If I don't get the probability of the intersection, then they are not independent. So here, probability of A times probability of B, well, that's 0.3 multiplied by 0.4, because that was the individual probability of A was 0.4, probability of B was 0.3. If I multiply them together, I get 0.12. Now, if you look back then, that is the probability of the intersection. So that does equal the probability of A intersection B, which means that these events are independent. So therefore, these events are independent. Now, the final question here is asking us to find the probability of A intersection not B. So if I'm finding the probability of A intersection not B, it can be quite hard to visualize. At the moment, we've done all of this just purely using number and the formulas that we've got, you know, your addition law, your independence rules, mutual exclusivity rules, and so on. We haven't actually drawn any kind of diagram, but because this is only two events, it would be actually quite easy to draw a little Venn diagram. So here is a Venn diagram that I prepared earlier. We want to find the probability of A intersection not B. So I'm just going to write that up here. Probability of A intersection not B. So let's put some labels on and let's start shading some things in. So here is my set A, here is my set B, and I want A intersection not B. So whenever I'm doing this, what I do is I shade each of these two items, and then dependent on whether it's the intersection or the union, I then look for either all of it together if it's the union, or just the overlap if it's the intersection. So here we're going to shade both of these things. Wherever it overlaps, that's the bit that I'm interested in. What I'm going to do first, however, is I'm going to fill all of the things in this diagram. So from earlier in the question, we know that this is 0.12. We know that the probability of A in total is 0.4, which makes this here 0.28. So 0.28 add 0.12 will give me 0.4. The probability of B was 0.3, which makes then this circle 0.18. 0.18 add 0.12 will give me 0.3. So if we add these three things together, so you get 0.4, 0.58, which makes 0.42, the probability on the outside. So this is my Venn diagram complete. I'm going to now start shading some things in. So we've got probability of A, so that's this one here. So that's all of my circle A hashed in. And then we've got here the probability of not B, so that's everything outside the circle B. So that's all of this stuff here. Now, because it's the intersection, what I'm actually interested in here is where it overlaps. So if we look at where it overlaps, you'll see that it's just this section here outside of the circle B. So it's inside A, but it's also just the bit that's outside the circle B, so it's 0.28. So here for part E, the probability of A intersection not B is 0.28. Again, we haven't needed to draw a Venn diagram for the entire question so far, but here it was very useful for us to draw that. So having a good understanding of what Venn diagrams are and how to draw them is very useful, and if that's something that you struggle with, then you should definitely look back through this chapter at the Venn diagrams exercise and just make sure that you're happy with how to draw Venn diagrams, put probabilities in, work different probabilities out from different areas. Okay, so that's it in terms of probability review. I'll do another one on the next topic, which is distributions, later on this week. But for now, review exercise chapter 12, that's on page 179 or page 180 of the textbook. Again, if you don't have a textbook, I'm going to take snaps of the pages in a moment and put them in the WhatsApp group. Hope you're getting along fine, and if you've got any questions, just drop them in the WhatsApp group.